So we've received some markups of unexpected design changes for our tank. These have all come about from some late changes made to the mounting frame, and so we need to make some adjustments to accommodate. There are 4 changes to make. The first is to deepen a pocket 75mm for the hanger frame. The next, to bring face A in line with face B. After that, reduce the overall height of the tank to 425mm from the bottom. And finally, compensate for the loss of volume by angling this face out a further 15 degrees. Simple. For each change, we'll make the first revision as you would in most any other CAD system, working with the feature tree in a history-based approach. Then, we'll make exactly the same revision using synchronous technology. To help compare, we'll set a timer going in the top right. So, history-based approach first. Now, some of these traditional CAD systems do have direct editing techniques, so let's trial that type of tool for our first design change, editing this pocket. No good. Notice that this fails, assumingly due to some downstream features. So we'll need to go back to the history of the model and modify this feature itself. To save you falling asleep, we'll speed up the video where we can. This is taking time because, as we edit the depth of the pocket, it's clear that another pocket is linked to match it. Design intent automation is usually seen as a good thing, but not when unexpected changes come about, as we have to find and remove that link. Okay, same change but this time using synchronous technology. Timer restarted, and we'll go through this in real time because it's as simple as placing a dimension in 3D, entering the required value, and notice the other pocket is left well alone. Done. Back to a history-based approach for the second change, matching face A to face B. As we edit the top feature holding face A, because history-based CAD is order dependent, the cut below that holds face B doesn't yet exist, so we can't match to it. Therefore we have to do some drag and drop reordering in the tree so that we can see what we want to match to. Oh, and notice some grey arrows that have just appeared in the tree. They're warning us that there's some kind of rebuild issue. We'll ignore these for now, but ultimately we need to come back and fix. The face angles need to match too, so we have to find the relevant feature and edit. This has had the effect of removing some rounds. Did we edit these rounds? No, but again, as one feature is delicately based on another in history-based CAD, often one change can turn into multiple changes. The clock is ticking. Let's take a look at how we'd make the same change in synchronous, including the draft. And don't blink or you'll miss this. 1 click, 2 clicks, done. History-based approach for the third change, to reduce the overall height. We find which feature is the correct one to edit, usually not the most obvious one. A little bit more sketch work required for this change. Oh, and once again some rounding to fix. Are you still following along? Does everything look okay? Are you sure everything rebuilt 100% correctly? This doesn't look like it used to do. Time for another fix, but good thing we spotted this before any moulds were cut. Could have been costly. Using synchronous technology for that same change, we can make use of any reference dimensions that we placed when we built this as a history-based model, but the difference is they'll actually control the geometry. Choose a dimension, enter the value, and let synchronous technology look after the rest. One last trip into the history-based approach, we need to increase the front angle 15 degrees to compensate for loss of internal volume from those other changes. Wait for the final rebuild, and wow, we have some big problems. There's a huge gap going through the middle of the part, the mounting holes in the top have also shifted, and some have even disappeared. Oh, and notice the red exclamation marks in the tree of failed features. We could spend many more minutes or hours attempting to fix this model. Or maybe it'd just be quicker to start again. And that same final change using synchronous technology, we use what we call the steering wheel for this, our main control in synchronous. We can use this to simply rotate around this round, and we can enter the precise value of 15 degrees. Done. All sorted, no rebuild issues. So, how did the times compare? 6 minutes 46 seconds for history based, 1 minute 15 seconds for synchronous technology. That's over 6 times faster. Well, even more than that in fact, because remember our history based model still requires work to fix. And it isn't just a time saver, it's a stress saver too. Keep Keep in mind that this part wasn't modelled wrong, it's just that when design intent changes unexpectedly, issues can arise in history-based CAD. Solid Edge with synchronous technology means you can welcome unexpected design changes, even late in the design cycle. Meet your clients' needs, improve your products. Solid Edge, design better.